Assalamu alaikum and welcome back. So today we are going to have lecture number 8. In this lecture we are going to do some numerical examples on how to calculate power and energy of signals, and we are also going to discuss the systems and some of the properties of the system. So until now we have done the classification of the signals, and we have also done the operations on independent and dependent variables. So we are just doing in this lecture and the previous lecture we were doing some numerical problems on how to on the classification of the on different classes of the signals, right? So today we are going to do some numerical problems on the energy and signal. So you understand that we have two types of signal that are continuous and discrete time signals, right? So these are the equations. You can recall that energy of a signal can be found by taking the x of t square and integrating it from minus infinity to infinity. So in case of the discrete time signals, we have discrete independent variables, so there we will just sum the independent values of independent variable, that is we sum the signal from minus infinity up to infinity and the square of the signal, so that will give us the total energy of the signal. Similarly, to find the power of a signal, we scale the same by 1 by t, that is power. We find the power by limiting capital T tends to 0 or tends to infinity, and 1 by t, and integrating the square of the signal over one period, that is from minus t by 2 up to t by 2, right? So in case of aperiodic signal, the period tends to infinity. So this is how we find the power. Okay, so this is the equation for finding the power. We have done this before, but I'm just writing it again so that you can know. Okay, and in case of a periodic signal, we find the power of periodic signal by integrating it over one period, that is from minus t by 2 up to t by 2, or you can also say that you can do it from 0 up to t or from minus t up to 0, but the main idea is that it must be integrated over one period. So the counterpart of the power signal in discrete time case will be, you can see that's exactly similar to what we have for the continuous case, but in case of discrete time signal, because the independent variable is discrete, so we will use summation instead of integration. So again, it's a similar thing, like there we were just integrating it from minus t by 2 up to t by 2, that is over one period. So here we can also integrate it from n equals to 0 up to capital N, or if we are doing it from minus n up to n, then we are scaling it by the factor of 1 by 2n plus 1, right? So that means so we are scaling by a factor of 1 by 2n plus 1, so it will result into similar values. Okay, then the third one is the case when we have a periodic discrete time signal. So for the case of periodic discrete time signal, we sum it over one interval and we scale it by 1 by n, which is by the period. So it's exactly similar to what we have for the continuous time case. Then we say a signal is said to be energy signal if it has finite non-zero energy. And similarly, for the case of power signal, we say a signal is said to a power signal if it has non-zero finite power value. So a signal which is a power signal cannot be energy signal because it will have a zero energy. And similarly, if a signal is energy signal, then it will have that is energy signal has zero time average power, and power signal has infinite energy. So let's use this definition and do some of the numerical problems, right? So these are some of the problems. I would like to go through them. I will solve some of them and I will leave the remaining to you to try it at your home. So let's take the first signal A. So we have to find energy and power of the signal. So by definition we know if a signal is non-periodic, then generally it's an energy signal, and if a signal is periodic signal, then it is categorized into a power signal. So an energy signal will have non-zero finite energy, and its power will be equal to 0. So let's find the energy of this signal. So we know by definition energy equals to integration from minus infinity up to infinity x of t square, right? So that means because this is again an example of the piecewise signal, so it has value equal to t for 0 to 1, and it has value of this, right, and it has value of this for this range of time. So that means 0 to 1 value of the signal is t, so we will square it because it's in the formula. So square and d of t plus, for the second interval it is 1 to 2 and its value is 2 minus t square, right, and dt. So by simplification, you know the t square, integration of t square will be t cube by 3, and the values for the variable are 0 to 1, right? Similarly, you can expand the signal 1 to 2, open the formula, so it will be 4 plus t square, right, and minus 4 t dt, right? So by integrating, okay, by putting values, so this, when you put the value you will get 1 by 3 because t cube, so 1 cube, okay, I'll do it step by step, minus 0 cube plus integration of 4 will be 40, so 40, and the values are 1 to 2 again, plus integration of t square will be t cube by 3, and again integration of the minus 4t will be minus 4t square by 2, and values of the limit are 1 to 2. Okay, so on simplification we get 1 by 3 plus 4 into value of the t, so that will be 2 minus 1, and again here integration is 1 to 2, so this will be 4 plus 2 cube minus 1 cube and divided by 3. Similarly, you cancel them, so you have minus 2, and then t square will be 2 square minus 1 square, right? So it will be something like, so you get 1 by 3 and plus 4, and then you get 8 minus 1, 7 by 3 plus 7 by 3. Okay, and from here you get 2 2s are 4, 4 minus 1 is 3, 3 2s are 6, so you get something like 1 by 3, 7 by 3 is 8 by 3, and 4 minus 6 is, so you get 8 by 3. Okay, that means 1 by 3 plus 7 by 3 is 8 by 3, and then 4 minus 6 is minus 2. So on simplification you get 3 here, then 8 minus 6, so you get 2 by 3, right? So since energy is finite, non-zero, so that means its power will be 0, so it's an energy signal with energy equals to this. You can also go to find the power for this signal, which will result into 0. Okay, so the second problem is this one. I just write few lines, hopefully you can do by yourself, right? So let's find the energy for this signal. So you know E equals to summation n running from minus infinity up to infinity, and this is x n whole square, right? So that means E equals to summation, right? So it's again an example of the piecewise signal, so it is defined over this range. So that means we have 0 to 4, right? And from 0 to 4, because it's less than 5 means 4, so from 0 to 4 it will be n square, right? So n running from 0 up to, right? For the second part it is summation, and we have n running from 5. You can see it is given here, it is 5 to 10, right? Because it's equal to, so that means it's this, and then we have 10 minus n whole square, right? So that means we can just write n equals to 1, so it will be 1, 0, n equals to 0, so 0 square is 0, plus 1 square is 1, plus 2 square is 4, plus 3 square is 9, plus 4 square is 16. Okay, that's all for the part first one. Now for the second one, we have 10 minus, so n equals to 5, so 10 minus 5 means 5 square is 25, right? Again, next value will be 5, then 6, 10 minus 6 is 4, 4 square is 16, then the next value is 7, 10 minus 7 is 3, 3 square is 9, and plus next value is 2, so 2 square is 4, and next value is 1, and 1 value is this. So by summation you can get. It's similar, right? Maybe I have made some mistake, but you can use the similar approach, right? So this is for the energy. So it looks that it will give you some finite energy, because we already know this is a aperiodic signal. So aperiodic signals are normally energy signal, right? So its power will be 0, because uh, we have, for the power formula, we have limit and the period tends to infinity. So when I divide this finite value by infinity, so I should get 0, right? So this again another signal. Okay, so to find the because it looks that it is a periodic signal. It doesn't it look, in fact it is a periodic signal. So for periodic signal, energy will be uh, infinity, right? And power will be non-zero finite value, right? So to find its power, we just simply write P, equals to 1 over T, and we integrate it from minus T by 2. We can also integrate it from 0 up to T, right? So you get same result. So that is x of t is basically uh, this one. So we say 5 cos of pi t plus sine of 5 pi t, right? And whole square dt, right? So you open the formula, then you see the square of the first term. You understand a plus b whole square, how to open it, right? So when you simplify it, it will be something like 1 by t, okay, and integration. So the first term, it will be like 25 cos square pi t, right? And plus, so I think you can do it, but I'll just similar, right? I just give you how you can find it, right? So for the case of square, you understand that cos square alpha equals to 1 by 2 plus 1 by 2 cos of 2 alpha, right? So that means I'm just taking this part, right? You understand, I'm just taking the first part because it's difficult to write. So I'm just taking this part, so you can do the rest by yourself. So if you take this part, then we have 25 can be taken out, so I just write 1 by, right, this is t. So you have cos square pi t. So cos square alpha is 1 by 2 plus 1 by 2 cos 2 alpha. So for pi t it will be integration, right? And this is 0 to t, and this will be 1 by 2 plus 1 by 2 into cos of rather I should write here also 0 to t and cos of 2 pi t. This is dt here and dt here, right? So this is your this one, then you continue same with the second part, this one, right? So hopefully you know that the integration of the sine or cosine, right? Integration of the sine or cosine over one period, it will result into, this thing will result into 0. And why it will be 0? Because if I plot the sine cosine, right, so this is something like this. So integration means, right, so integration means summation of this, right, a type of, you can say, summation or addition. So if I sum this whole over one period, right, you see these are the positive values, right, up to here these are the positive values and these are the negative values, right? So because positive values and negative values are the same, so when we sum them it will result into 0, right? Sum of the sine or cosine, or maybe if I plot the sine, that looks very easy to understand. So this is the sine waveform, right? So you see these are the positive values and these are the negative values. If I sum this whole, it will result into 0. So that means either sine or cosine, if we integrate it over one period, it will give you 0. So you get 0 here, right? So similarly you can do for all the rest of the terms, and I hope you can do it. Okay, so I'll leave up to here, or you want I can just solve up to the first term, that is, this is your this, so it will result into 25 by t, and the integration of 1 by 2 will be uh, uh, 1 by 2 t, right? And the uh, interval of integration is 0 to t, so by putting value this, right, and plus 0. So this is for the first part, right? So when you put the value, so you see that if I replace t with 0, it will be 0, and if I replace it with capital T, so it will be capital T minus 0 results into 0. So that means I get something like this for the first part, 25 by t into t by 2. Okay, so uh, t cancels with t and you get 25 by 2 for this part, right? Because it will consist of a plus b whole square, so it will be a square plus b square plus 2ab. So I have just done it for a square, right? So you can do for the second part and for the third part. Okay, so after that summation you will get the answer, which will be, the overall answer for this will be 13. Okay, so do it by yourself. Then we come to the next type of question, with signal, which is, you can see this is a periodic exponential signal, right? So when this periodic exponential signal, the absolute value or the magnitude of this signal is, right, you understand, we have okay, let's go back to the FSC level maths. You have done that, you have some z equals to uh, a plus j b, right? So this is your complex variable z. So you understand it has real and imaginary part, so you can express this signal in, this is what is called the rectangular form, right? Rectangular, right? So you can also express the image, the complex number into polar form. So in polar form we say that z equals to uh, magnitude, right, and phase. So you represent phase like this, j of something, right? So if you compare this, so you can see that this is a complex exponential signal, and it has real part it is in the polar format. So when there's nothing here, that means 1 is here, so that means magnitude of this is equal to 1, right? So magnitude of this signal equals to 1. So that means if I want to find I can say the x2 of n, right, magnitude square will be equal to 1 square, right, which is equal to 1. Okay, now to find its energy, we say for E equals to summation and running from minus infinity up to infinity x of n, right, square. So by putting value, we know that uh, n running from minus infinity up to infinity, we know that the x n square absolute value for this signal is 1. So that means if I sum this from minus infinity up to infinity, that means if I sum it, right, infinite time, it will result into infinity, because at minus infinity there is 1, right? So at minus 100, minus 50, minus 10, 0, and at 1, 2, 3, at 100. So from minus infinity up to infinity, it has the value of 1. So if I sum this 1 infinite times, so it will result into 0. So that means it has 0, it will sum into infinity. So that means it has infinite energy. So something has infinite energy, we cannot call it an energy signal, right? Now let's see what is the power of this signal. So you understand, to find the power of a signal, for the case of discrete time, we have period equals to n. So it will be summation and n running from 0 up to n minus 1 and x of n, right, absolute value square. Okay, so by putting value, we can find that 1 by n, right, and this is summation over n equals to 0 to n minus 1, xn square is equal to 1, right? So if I sum it from n equals to 0 up to n minus 1, so it will simply result into 1 by n is the scaling factor, multiply by, because I am summing this up to one period, so that means I should get 1 multiplied by n. If n is 5, so I will add this 5 times. So if n is 100, so I will add it 100 times. So that means whatever is the period, it will be 1 multiplied by the period. So you see that n cancels with n, so I get power equals to 1. So if any signal has power equal to 1, we say that it is a power signal. So I hope this gives you idea how we can find the energy and power of a discrete time and continuous time signal, right? Because the signal is already in the complex, in the polar form. So in the polar form, we have magnitude times the phase. So the magnitude of this is, because it's not mentioned there, so that means it will be 1. Like similarly, say a into x. So what is the coefficient of x? That is a, right? But if you have x, then we say its coefficient, because it's not mentioned here, so that means it will be 1. So I hope you understand, these are quite basic things. So this is how you find the energy or power of a discrete time signal. So how to find the energy and power of this signal. So I hope you understand, because this is a discrete time signal, so to find its energy, you understand, we can simply write E equals to, right, so summation n running from minus infinity up to infinity, and it will be cos of n whole square, right? So squaring this results into, because we know cos, I think I made just a bit mistake here, so it's actually cos of pi by 4 n, right? And now it is square. So you understand cos pi by 4 n, right? This is, and this whole square equals to cos square, and it is equal to 1 by 2. We have just done this, 1 by 2 plus 1 by 2 cos of, you know, cos square alpha equals to 1 by 2 plus 1 by 2 cos 2 alpha. So if I replace, if multiply it by 2, so I'll get pi by 2 n, right? So this is what we get. Now you can know that if I sum this from n equals to minus infinity up to infinity, is 1 by 2, okay, and plus summation n running from minus infinity up to infinity is 1 by 2 the scaling factor, and I have cos of pi by 2 n, right? So if I think you can know that if I sum this from if I sum 1 by 2 from minus infinity up to infinity, so it will result into infinity. And this one is somehow if you sum it, so it will be like uh, near to 0, right? So 0 plus this will result into infinity, because this part gives you infinity. So that means the energy of this signal is infinity. So if energy is infinity, that means it is not an energy signal, right? So how to find the power? So you understand, that's straightforward. You just say P equals to 1 by n, right? And summation over one period, that is n equals to 0 up to capital N minus 1. So that means it is something cos of pi, because you understand cos square, right? So I just copy these values. You understand that cos square pi by 4 n, right? Cos square pi by 4 n equals to uh, 1 by 2, right? And plus again this is 1 by 2 summation n running from minus infinity, right? So again here we have 1 by 2. I hope you understand. If you don't understand, then I can say okay, uh, this is okay, the factor I have taken common here, so that's 1 by 2, and in this case n running from 0 because we are taking the average value, power value. So for power calculation we sum it over one period. So this is 1, and I get cos of pi by 2 n, right? So you understand summing or integrating the cosine or sine over one period results into 0. So that means this is 1 by n, and you see summing 1 by 2 over one period is something like 1 by 2. We have previously done this, multiply by n, right? Because it will be n time. If you are summing 1 by 2 one time, so you get 1 by 2. If you summing it two times, then you say okay 2 into 1 by 2. If it's summing it three times, then it will be 3 into 1 by 2. Now because you are summing it over one period, which is n, so you say okay 1 by 2 into n. So you see n cancels with n, so the power of this signals comes out to be 1 by 2 because this is finite non-zero value. So we can say this is a power signal, right? So we have we have had different examples for the power and energy. The signals were sinusoidal, so you understand how to find the power and energy in case you have the signal sinusoidal, in case you have some exponential signals, right? So you also know how to find straight away. You know the equation, you just put the values. So I have tried to give you the idea of how to find energy in different multiple types of signals, right? So for the rest of the problems, I would like you to go and do it by yourself, right? So if you have any confusion, you can ask me in the live session. So that's another topic, that is we have done the step functions and a ramp function and different functions, right? So now this is the example of how you can plot, right? So you get better idea, right? So the first one I am going to do it for you, and for the rest you should do by yourself. Okay, so you can do by yourself. Okay, so if you look at this one, okay, here it is u of t plus 1. So you understand what is u of t. So u of t is a step function and it is discontinuous at 0, right? So that means it has value of 1 on 0 and also on, right? So it has value of 1 at 0, and at the same time it has value of 0 at 0. So that means it is discontinuous at 0. Okay, so this is how you plot the u of t. Okay, now if we look at the first term is u of t plus 1. So you see this is a step function, but it is a shifted step function, right? So by looking at the equation, you know whether it's a shift left or shift right. So if you compare it with the standard equation, you know u of t minus t naught, right? So t naught here is minus 1. Okay, t naught here is minus 1. How we know that? Because in the formula it is minus, but we get it's plus. So that means if this 1 has negative sign, then this negative and the original negative sign in the equation, this will make it plus 1, right? So that means this is a minus 1. So if you shift by amount of minus 1, that means you are shifting the signal by uh, left side, 1 unit left side, right? So if I plot the signal of the first term, it will be something like this, right? So this is right. So this is your t, and this is u of t plus 1. Okay, then for the second case, you have second term, that is step function, but it is scaled by a factor of 2, and it is also inverted, right? So that means it has a negative value. So let me plot the second one. So let's take this as, yeah, okay, let me just, okay, so okay, so this is 0 and this is -1. Okay, let's plot another waveform here. Okay, so this is the 0 point, and to plot u of t, right, -2 u of t, right, so -2 u of t will be something like, right, so this is -2. Then the third part is u of t -1. So you see, because if you compare with the standard equation, so you know that the third term in this equation is shifted 1 unit to the right. Okay, so let's draw this another signal, the third one. Okay, and we shift it 1 unit to the right. So this is u of t -1. Okay, x of t is basically summation of all these. So if I sum all these signals, okay, let's I plot it here. So to plot the x of t, we can just say, okay, I redraw here because there's some problem with the software side. Anyway, so this is your step function. Okay, let me draw the axis first. So this is your resultant signal. Okay, so that's your first signal. That was step function shifted 1 unit to the left. Then we have another signal, that is u of t, right, this -2, and the third signal, it was 1 unit shift here, right? So if I, the output signal is which is x of t, the resulting signal is x of t, which is the summation of this. So if I sum this, I will get x of t. And how I get x of t? So you see from here, which is -1, to this one, to this side, all this, in fact from 0, if you just look at this one, this is your 0 point, right, this is 0, this is 0. So from 0, from -1 up to 0, this signal is 1, this is 0, this is 0. So summing 1 with 0, 0, 0 will result into 1. So that means I get 1 here, right? This is the x of t, which is the resulting signal obtained after adding these, right? So this -1, so from -1 up to 0, it will be 1. Again, from 0 up to this is 1, right? So this point is 1, and again this point is 1, right? So from 0 to 1, this signal is 1 and this signal is -2. So 1 -2, so you get -1. So that means something like this. Okay, then from 1, this is 1, this one is 1, so 1 plus 1 2, and this is -2 0. So that means from 1 onwards this will be 0. So this is 1, right? Amplitude here, this is +1, and amplitude here, this is -1. So I hope you understand that how the waveform, how I sketch the waveform for the resulting signal x of t. So that's all for this topic, and I want to I want you to sketch the waveforms of the other examples as shown on the previous slide. So let's that's all for the signals part. Let's jump to the next part, which is the systems. So system is anything that generates a signal, that transmits a signal, that receives a signal, or that processes a signal, right? So in general, we can say anything is a system that performs some operation on the signal, right? From generation up to the transmission and up to the reception, all the things involved are called system. So a system may be made up of physical components such as an electrical circuit, mechanical systems, etc. Or it may be an algorithm that computes an output from the input, right? Like software realization. Continuous time systems transforms the continuous time input signals into the continuous time output signals, right? So we represent this by an arrow, right? So it's a norm that the input is represented by X and the output is represented by Y. So for example, in case of continuous times signals and system, so X of t will be the input and Y of t will be the output. Similarly, for the case of discrete time signal, xn is the input and y of n is the output of the system, right? So here are shown two systems, one discrete time system and one continuous time system, right? So this is the discrete time system, right? So input is x of n and y is y of n. So systems can be represented by different representations such as block diagram, like we have represented here, that we represented the system by the block, or it can be represented by mathematical equations such as this one, or it can be represented by the operators such as this one. For example, here you see that y is the output signal, x is the input signal, and we perform some operation h, right? For the case of continuous time, this one, and for the case of discrete time, this one represents a system. I think we have discussed in the previous lectures, in the early lectures, so I will go right. So uh, example of the continuous time system is electrical circuit. For example, we have this RLC circuit, where you understand this symbol represents the inductance or inductor, this is resistor, and this is the capacitor. So this is the electric system, and we can also represent it using the differential equation as shown here. So as we have discussed in the previous slide, that we have different representations for the system, right? Then the next topic is systems interconnection. I will go quickly through them because you understand you have done this so in so many different subjects. So we have a cascade, so you understand in cascade, which is also called a series, right? So we have first system, the output of the first system goes into the input of the second system, and so on, right? So for example, we have a radio receiver. So in radio receiver, we have a receiving circuitry, which is followed by an amplifier. So whatever the input is received by the receiver, that is amplified by the amplifier, right? Parallel, so in parallel systems can be connected in parallel, like you know this one, right? So similarly, in case of electrical, you understand you can represent a you have a series representation of resistors. You can also have the parallel representation of the parallel connection of the resistors and capacitors and so many things. So I will just not go into details here, right? Or another connection you understand is series parallel, like this one. So this is the series parallel circuit. You see these two systems are in series, whereas this one is in parallel with this one. Again, the output of this goes to the another system which is in series, right? And you understand, in case of feedback system, so the output portion of the output is fed back into the input, so such a system is called feedback system. So I will just not go into detail here. Then we come to the next topic, that is the classifications of the system. Our system classifications are, they are also called the properties of the system. So I think for today it's sufficient. We end here, and from the next lecture we will start discussing about the different properties of the system. So until then, goodbye.